All right, there we are. Welcome, everyone. So glad you all are here. I hope your school year is going well, and you all have some fun things planned for the summertime. But between now and then, I'm hoping we can spend some time talking about struggle and why it actually might be a good thing to ask our students to do from time to time. Before we get going, we'll just maybe take a moment to get a little bit get to know each other. You heard about me, so now it's your turn to share a little about you. So if you wouldn't mind in the chat, one or two questions. Feel free to answer whichever ones you like. What brought you here, and what do you hope to gain from being in today's webinar? Connecting this to building thinking's classrooms work. Yeah, absolutely. I can see that. Strategies to help students get over their fear of math. Oh, okay. Let's go. That's an important one. Assist students in preparing for the CASAS and the high set math exams for adult school. Okay, yeah, there's probably going to be struggle with those tests for sure. And I mean that in a good way. Would like to know how to harness the struggles and self-doubt they experience. All right, thank you all for sharing. Maybe hold off a moment or two more, see if some other messages will show up in the chat. All right, the topic is relevant. Yeah, okay. Yes, strategies to share with colleagues. Absolutely. Hopefully, something that you get from today, you'll be able to take with you to share with others in your network. Oh, a repeat participant. Hey, welcome back. All right. Well, thank you all for sharing. And for those of you who are just coming in, or if you want to hear it again, so I'm Matt Wallace, and I'm here to chat with you all about struggle. So here's the agenda for our time together this afternoon, some housekeeping things, and then I have a math problem and a question that I'll invite you to participate in. And then we'll talk about struggle and how we might be able to support struggle with the students we work with. Um, if all goes well today, hopefully by the end, you'll be able to describe the role of productive struggle in math and have at least one strategy that you can use to support productive struggle with your teaching to support your students. So with that, a couple of housekeeping things. Norms, one, I'm going to do my best to manage the chat, and there's some other folks here from CalPro who will manage the chat as well. So I invite you at any point in time, post questions, make comments, share insights, any way you want to use the chat, by all means, please do so. And I'll do my best to address, manage, or answer questions as they pop up. I might not answer them right away, but don't worry, I will get to them, and there'll be a time at the end for question and answers as well. So please don't let me not answer your question. Hold me to it. If you put it in the chat and I haven't answered it by the time we get to the end, remind me, and I will gladly answer any and all questions that you might have. Another norm I'd like to encourage you all to engage in is to step outside of your comfort zone now and beyond. And I mean that in a good way, as you see here. Stepping outside of your comfort zone, I really believe, is where the learning happens. And stepping outside of your comfort zone is going to look different for all of us. For some of you, stepping outside of your comfort zone might mean just thinking about these ideas a little bit longer than you might normally because they're so different or foreign to you. And so rather than dismiss them or just forget about them and move on, maybe you spend some more time really wrestling with the ideas or thinking about how you might be able to use them. For others, stepping outside of your comfort zone might mean taking these ideas and trying them out with some of the students you're working with. And still, for others, it might mean you're sharing these ideas with colleagues and encouraging them and supporting them to maybe implement some of these ideas. Whatever stepping outside of your comfort zone looks like, your students will be the beneficiaries of your learning, and that is what I'd argue is the most important thing. All right, with that said, I have a problem and a question for you. We'll start with the problem. Ant, Aunt Martha, she has 5 trays of cupcakes. And she is describing how these cupcakes are arranged. There's 100 total cupcakes on all the trays. The first and second cupcakes have, or the first and second trays rather, have 52 cupcakes. The second and the third trays have 43 cupcakes. The third and the fourth trays have 34 cupcakes. And the fourth and the fifth trays have 30 cupcakes. No question yet. Rather, what I'd like to invite you to do now for the next 60, 90 seconds is to describe this problem in your own words without using any numbers. You can do it in the chats. If you have something open on your device, you can do it there. You don't have to share it. Or maybe if you're old school and you got paper and pencil or pen, whatever works for you, I invite you to take this time just to describe what's going on here without talking about any of the numbers that you see in this problem. And I'll start the timer and mute myself so you have some quiet time to work. All right, that was a minute, not a lot of time, but hopefully enough for you to get your initial response down. And now what I'd like to ask you to do is to draw a picture that illustrates what's going on in this problem. And I'd like you this time to include all the numbers that you see. So you can do it next to, I don't know if you can put a picture into the chat. I suppose you could take a picture of it and upload it if you like. I won't require or ask you to do that. But if you could, please take a moment to try and illustrate what's going on here and make sure the numbers are included in your illustration. And again, I'll mute myself and give you a minute for work time. All right, another minute is come and gone. Hopefully that was enough for you to do your drawings. So some people included in the chat. Thank you for sharing. So let's see. Someone said, well, um, there's some trays of cupcakes. They've been arranged in unequal quantities, totaling to 100. Not sure what we need to do with all that information yet. Great. Someone said, well, we need to examine the relationship between the trays and subtract to compute. All right. Well, I'd love it if you could upload your pictures, but like I said, no worries. We won't go there today. Here's the question for you. How many cupcakes are on each tray? So now that you've thought about what's going on here and you've drawn a picture, I'd like you to now dive in and try to come up with an answer for how many cupcakes are on all of the trays in this problem. I'll again mute myself and give you some time to work. You are not required, but if you're interested in sharing your answers in the chat, by all means, please feel free to do so. And I'll give you a few moments to work. 30-second warning. Please take another 30 seconds. It is absolutely okay if you don't get an answer. Just spending time on this problem is perfect. All right, we already have two hypotheses of how many cupcakes are on each tray. I am going to show you the answer in a moment. If you don't want to if you don't want to know what the answer is, I won't say it out loud. I'm just going to show it on the screen. So if you don't want to know the answer, now's your time to look away, and I'll let you know when you can come back. Here's the answer. All right. You can look it back again if you didn't want to know the answer. Hopefully, you didn't see it. You can continue working later. Now I'd like to pose a question, and that is, how would you complete the sentence above? Learning is blank. And I invite you to answer this question in the chat if you like. While you're doing so, I'll share that, well, uh, not too long ago, I was at a conference, and one of the talks that I went to, the speaker said something about learning that I thought was so profound that it really stuck with me ever since. And thank you for all the people who are saying things in the chat. Learning is lifelong, fun, engaging. What this person said about learning is that learning is not intended to be easy. It is, however, intended to be rewarding. My guess is that many of you here can relate. If you've ever had to learn anything hard, or if you've ever had to learn anything worthwhile, you know that learning is rarely straightforward, and it certainly isn't effortless. Instead, learning involves struggle, it involves mistakes, it involves hard work. You might feel confused or frustrated at times, maybe even doubt yourself. You might have to do some time and some practice, reflect on things. You certainly are going to need to persevere. But once you figured it out, once you've had that aha moment, no one can take those new insights, that new learning, nor the sense of satisfaction away from you. And that's really the reward. So today we're going to talk about struggle and how we might be able to support our students with really this important part of learning. And I would add that while we're going to focus primarily on struggle, a lot of the other things that you see here, I think could easily be, we could apply a lot of the things we're talking about to some of the things that you also see here, whether it's mistakes, anxiety, challenges, and so on. All right, so here's some things that we know about struggle. One is that struggle and mistakes are perhaps some of the best time for brain growth. And this comes from Jo Boaler. In her book, one of the things she talks about is how whenever students make a mistake, or anyone really makes a mistake or struggles, a new synapse grows. And by synapse, I mean that's how the network in our brains. That's really where these new neurons form a connection, and that's what we would call learning, or a new memory is formed. And that's not just because a mistake has happened. You can't just go around purposely making mistakes and expect your brain to have all these new synapses. But rather, the mistakes and the struggle lead to learning, because those are the times when you're really thinking hard about something. You might be coming at it from different ways. You're taking something, turning it over on its head, and really trying to look at it from a new way. You might be just dwelling on these things for quite some time until you reach that point where you figured it out. And that's really what leads to the brain growth. Not just the mistake, but all the work that led into that mistake, and even the reflection that happens afterwards. Why did I make that mistake? What's going on here? What might I do differently next time so that I don't continue to make those mistakes? Those are the things that are really, really powerful for brain growth. So we know that struggle and mistakes are really important for learning, so much so that many are saying now that it's a necessary component of learning math with understanding. So because learning isn't really intended to be easy, we know that all the things that are going along with mistakes and struggle are really just a natural and normal part of learning math with understanding. So it's not something that we want to avoid, and not something we want to save our students from, but really just part of the learning process in general, and not something we should shy away from at all. And these two things really speak to that. But I think more importantly, I think this quote really captures all the things I'm trying to say. So I want to give it some voice. In many cases, struggle can be not only productive, but also desirable. For students, productive struggle can provide opportunities to delve into understanding mathematical conceptions or concepts and relationships instead of merely looking for correct answers. For teachers, students' productive struggle can provide opportunities to gain understanding of students' mathematical thinking. Thus, productive struggle affords rich learning opportunities for students and teachers alike and should be viewed as an essential part of mathematics instruction that promotes learning with deep understanding. So mistakes and struggle are good, and really a normal part of what happens when people are trying to understand and make sense of some math. We also know, however, that we are often led to believe that struggle in math is a sign that we are somehow less capable of learning math, or that struggle is, quote, wrong. We internalize our struggles and begin to overlook or undervalue our potential. We allow our struggles to define our mathematical potential and fixate on what we cannot do. So for all the good things that come along with struggle, there's also a stigma that comes along with struggle. And while it is a good thing, not too many people are realizing or embracing the struggle. So they're missing out on really rich opportunities to learn because struggle can be scary, because struggle might have a negative connotation, because struggle is uncomfortable. But really, that's an important time for our students in their learning and for us as teachers as well. Why might this be the case? Well, it just so happens that here in the US, anyways, a lot of the things we do as teachers don't ask our students to engage in struggle. A lot of the things that you see here are neat tricks that we might share with our students so that they can get answers and really avoid all the struggle, but they don't give our students opportunities to engage in struggle. And so one of the things they'll take away is that I shouldn't be struggling at all. I just use these neat tricks and I should be able to get answers quickly. And that math isn't or should not involve the struggle. And if there is some struggle, then perhaps maybe I'm doing something wrong because these tricks are really fast and efficient, whether you're doing work with division and fractions and you teach them to just keep flip change, or maybe use PEMDAS, or please excuse my dear Aunt Sally, as a nice trick for order of operations. Or you can see some of the things here like a butterfly method when students are working with fractions or proportions. Or FOIL, there's a classic one when students are working with quadratics and binomials. And again, they work well, but they're nothing more than tricks, and they avoid the struggle. A lot of the textbooks and curriculum we use as teachers too also doesn't ask our students to engage in many tasks that would involve struggle. And some of the things that you see here are just headline. Well, one on the left, there's a headline: middle school math assignments are aligned to the standards, but they're not really rigorous. So we're not really asking our students to engage in a lot of struggle. So one of the takeaways there is all the work that math is, as identified in the textbook, isn't really about struggling. It's about trying to get answers and get things quickly. And for those of you who might be using Teachers Pay Teachers or Pinterest, these pie charts are representative of the types of tasks that you might find on those websites. And the tasks that involve struggle are really hard to see here. They're the green slices in the pie chart, and the green is so small you can barely see it. It's in the pie chart in the middle. It's the 0.7%. And in Pinterest, the pie chart on the right, it's 0.8% of the tasks that are on Pinterest, and 0.7% of the tasks on Teachers Pay Teachers are the real, genuine problem-solving tasks where our students might actually struggle. All the other tasks are really straightforward, might even involve some of the tricks that avoid struggle and don't ask our students to do some struggling. We also know that as teachers, we identify struggle as maybe something that is an indication we've done something wrong. So we want to jump in and we want to rescue our students from struggling. And this happens so much, it has a name, actually has a couple of names. Sometimes it's called the universal helping interaction, or sometimes also called the didactic contract. But it goes something like this. As soon as a student is working on a task and they're unsure of what to do or they're struggling, they call the teacher over for some help. And that's where the contract begins. And as part of that contract, it's the teacher's job to lay out everything, all the steps, show the student exactly what to do, remove the struggle so that the student can arrive at an answer without feeling any of the struggle or the anxiety or the frustrations or anything that goes along with that. And for the student side, their part of the contract is they must listen to all the things that we ask them to do step by step, whether in question form or whether we explicitly say, do this, do that. to get an answer. And that's the contract. And while we might help our students get answers, we're also removing all of the struggle that the student might be feeling as part of that work. And remember, the struggle is actually a good thing. So the fact that removing that is really doing our students a disservice. So learning is good, and we want to try to avoid some of the things that might be happening in classrooms or with students that we're working with, whether it's the tasks that we ask our students to work on, whether it's the tools, the curriculum that we're using, whether it's just when our students say they need help and we want to dive in and just save them right away and tell them exactly what to do and how to do it. And so they don't have to struggle. We want to avoid those things. And in replace of those things, a couple of things that are really important to help our students. First, we want to make sure that struggle is normalized. So for all the reasons I mentioned earlier, students might feeling like struggle is a bad thing. So we want to create an environment that encourages struggle and helps our students realize that it's actually an important thing and not something to be avoided, or not an indication that the students are less than, not good at, or just not a math person. So what are some ways that we might be able to normalize struggle? Well, one thing is we can talk about struggle. Not only is it important for us as teachers to share the times that we're struggling with our students, but we also want to talk about other people who are struggling and the things that they've done to persevere and benefited from the struggle. And part of that can be through research, part of that can be through articles, part of that can be through just anecdotes, stories you can talk about in your own experience, whether you're talking about other students you've worked with in the past, whether you're talking about teachers you might have worked with in the past, family, and so on. And you can see here from the quote, when students know that mistakes and struggle are important times for the brain, they become much more willing to struggle and try harder in math and keep going. So you don't really have to spend any time looking at these things here. These are really just articles that you can Google. If you just Google math and struggle, you can probably find a whole a wealth of articles that you can share with your students. And you don't have to actually share these articles with students, but once you read them, you now have stories that you can tell. And when they're struggling, you can say, hey, I was reading this article the other day and it talked about how important struggle really is. I can share it with you if you want, but let me tell you what I learned from reading it. If you are interested in finding some research or some stories or articles about struggle, one great resource I think is U-Cubed. And you can see this is a screen grab of the main page on their website. And there's lots of resources on here. They're great for students of all ages, including adult ed. One of the things in particular you might want to find is clicking on ideas. And ideas, you'll find lots of research and resources to talk about why struggle is valuable. Same is true with evidence. Once you click on evidence, you might get some more real researchy things that are getting into struggle, written for a general audience, to be sure. So don't stray away from them. But definitely a great resource. I encourage you to check it out if you have not done so already. There's lots of good things on there that talk about struggle. But one of the most important things is that you're just talking about it, and talking about it, you normalize it. It becomes normal when you talk about struggle on a regular basis. So your students begin to see struggle as something that just happens all the time, sometimes in math, sometimes in other places, but it's normal. Other things you can do is establish norms for struggle. So by norms, I mean, when I talk about a classroom norm or a norm for today, you want to talk about what does it look like? What does it sound like? In this case, when students are struggling. So a couple things you can do. One is you can have things on the wall. Or you can give your students, you can make a copy, a document, a Google Doc even, something you can share with your students so that when they get stuck, they have a variety of different strategies they can try, whether it's guess and check, whether it's draw the problem, whether it's they try a different strategy. Maybe it's they work backwards. There's lots of different problem-solving strategies that you can offer up for your students. And this isn't to say that you want to tell them which strategy to use. You just want to provide a menu so that they know, hey, when I'm struggling, here are lots of different things that I can do when I get stuck, when I'm struggling, when I'm uncertain about what's going on. I have some resources that I can make use of. Here to really talk about what happens. So on the left, you see some resources. What are some resources when you get stuck? And you can offer up these for students to use. They can use the internet. If you're really wanting to go there, you can ask them to use AI. It's here. Might as well embrace it. They can talk to a neighbor or a classmate or a friend. They can use notes if you have students who are in classes and there's lectures and instruction and you have notes that they take. They can use you. They can that for support. There might be a calculator they can use. There might be an old book, a textbook they can resource. And so on. So those are the resources, but what does it look like? What does it sound like? What does it feel like when you're stuck and when you're trying to persevere? Well, that's the things that you see on the right there. And so really trying to, in this case, help students realize that when they're feeling those things, it's normal. Hey, what does it look like when I'm persevering? I'm working on something for a long time, and that's okay. I don't have to answer every question quickly. What does it sound like when I'm persevering? There might be quiet for a long period of time and there's nothing wrong with that silence. There might be a sigh. Oh, this is hard. Yeah. But that's an indication that they're right where they should be. That's part of the persevering. That's part of persisting. And when they're doing those things, they should know that this is okay to do. This is just a natural, normal part of the learning process. And I'm struggling, and that's okay. And the feel like thing is the same way. And then something else you can do, here's another image that a teacher came up with their students, and they talk about a pit. And so at various stages of learning, they're going to go from one side to the other side, and they're going to have all the feels, all the things that you see there. They're going to start in the beginning, not understanding it. Then it's going to feel like this is really hard. I don't know if I can do this, and they want to quit. I don't really, I just want to throw in the towel. But if they stick with it, they'll reach the bottom of the pit, and then they'll find their way working themselves back up. And while you don't necessarily have to give your students this pit, the idea here again is that you're helping your students realize what it looks like, what it sounds like when you're struggling. And being able to point to those things and put a name to it helps your students realize that, struggle is something that's normal. And this is where I am in the learning process. And I know that I can continue on and eventually I can get to this part and this part and hopefully get to that aha moment. And that's where the reward is. In addition to talking about struggle and helping your students realize what it looks like, what it sounds like, it's also really important that we value it. And so for that, I want to invite you to scan this QR code. And I think there might also be a link coming up in the chat if you want to click on that. And I'd like to ask you to read this short vignette of two teachers and how they are dealing with struggle and with their classrooms and their students. One might be valuing struggle a little bit more than the other. So as you're reading, two questions to think about, how are these experiences different? And what appears to be valued in both of these classrooms? So I will mute myself now and let's do 2 minutes. So in 2 minutes, we'll come back and continue on. All right, that was 2 minutes. How about another 30 seconds for those of you who are continuing to read? And the rest of you, I invite you to put your answers to these two questions in the chat if you've already finished. 30 more seconds. All right. So, hey, um, differences. So, in I don't know if I'm pronouncing this right, in Miss Flahive's class, as soon as students said they didn't know what was going on, she stepped in and showed them step by step what they should use to answer the problem. In other words, she rescued students from the struggle, from maybe making mistakes, or maybe even failing. So students didn't get those opportunities. They get an opportunity to feel the struggle. They get an opportunity to make mistakes and learn from them. And so the message is that if you're struggling, I'm going to come and I'm going to rescue you because I don't want you to struggle. In fact, struggle might be a bad thing. So I'm going to save you from it because really what I want is you to get an answer. In Ms. Ramirez's class, on the other hand, same scenario. So the students said, hey, I don't know what's going on here. And the teacher, rather than give them an answer, elicited ideas. Hey, what are some things that would be helpful? What is it that you already know about this problem? And then after students had a chance to brainstorm some ideas, she encouraged them to try some things out for themselves. In this case, she's saying, you're struggling, and that's okay. That's actually a good thing. And I want to be here to support you and give you the tools that you need, but I'm not going to rescue you from the struggle because that's a normal and natural part of the learning process. And I want you to really lean into that. So when I say value struggle, it's really important that we can't just talk the talk, we got to walk the walk. So if you want to spend the time and really set the foundation to let our students know that struggle is a good thing, it's also important that we make sure that our students engage in struggle and we don't um, uh, remove those opportunities from students, for our students, rather. Okay, so in addition to creating an environment, oh, sorry, I think this quote, I wanted to share this quote because I think it really gets at all the things we've been talking about so far. Teachers greatly influence how students perceive and approach struggle in the mathematics classroom. Even young students can learn to value struggle as an expected and natural part of learning, as demonstrated by the class motto of one first grade math class. If you are not struggling, you are not learning. Teachers must accept that struggle is important to students' learning of mathematics, convey this message to students, and provide time for them to work through their uncertainties. So you can say mottos like, if you're not struggling, you're not learning. In my class, one of the things I often said to students is, if it don't burn, you don't earn. In other words, you might have that burning feeling in your head, but that burning feeling means you're earning, you're learning, and you're growing, and that's a good thing for students. So after making sure that our students really understand that struggle is normal, now we can actually engage our students in some struggle and help and allow them to benefit from it because they're now realizing that this is an okay thing and actually I might be gaining from these opportunities. So it's really important to give our students as many opportunities as possible and then to support them, not rescue them from the struggle. So what does that mean? Well, one of the things we're going to want to do is give our students tasks that are going to lead to some struggle. Many of these tasks are probably going to be reasoning and problem solving tasks. Some examples you see here and some non-examples. So both of these tasks are about volume. The example involves a moving truck and some boxes. And the questions are about how many of these boxes can I arrange in this moving truck? And you can organize them in any way that you want. But how many boxes can I fit in here? And on the right is a shed, and it gives us the dimensions, and it asks us, what's the volume? And you might not even know what to do here, but with these numbers, you might just go ahead and multiply them together or add them together to arrive at an answer. So I won't ask you to engage in the non-example, but take a minute. Think about how would you answer the example with the boxes? Are you thinking about how to organize the boxes? Are you already crunching numbers? Does it matter the size, how many boxes you can fit, whether you have them leaning one way or the other way? Or maybe you flip them on their side. Does that matter? Now you're really thinking about volume in a whole new light, not just length times width times height. Here's another problem. So both of these, believe it or not, are about the Pythagorean theorem. The non-example on the right gives us some triangles. We know two of the sides, and it asks us specifically to use a squared plus b squared equals c squared to find c, the missing side length. The example, on the other hand, has to do with an orange. And you might notice there's not even any triangles there. You have to decide if it even makes sense to use a triangle here. You might not even realize that this is about the Pythagorean theorem. It is, and the Pythagorean theorem is, in fact, one way that you can arrive at an answer. But now you're really wrestling with what's going on in this problem. I'll give you a minute to think about, where do you see a triangle? Do you even see it there? And in that case, you can see how triangles might be utilized in novel contexts. And you might be struggling with or wrestling with, well, how am I going to figure this out? What does this make sense? Where are the information that I can use? All those things, part of the problem-solving process. Here's another example. Hey, there's a tray of cupcakes. And it just so happens that they're organized in different quantities on each of these cupcakes. And this is not a straightforward problem, and you got to think about, well, how am I going to do this? How am I going to solve this? There's a number of different ways to do that. And still another opportunity to engage your students in some struggle. One way to do it is with creating a system of equations. I don't know if any of you did that with modeling, but that is one of many ways you can answer this problem. All right, so what do I mean by tasks generally? Now we've looked at some examples and non-examples. Well, take a moment to think for yourself. How would you describe the examples and the non-examples? And how do they compare with the kinds of tasks you might be asking your students to do? Or are you currently giving your students tasks that engage them in reasoning and problem solving? Do you need to change things up a little bit so that your students have more opportunities to do so? I won't ask you to do this in the chat, but food for thought to be sure. So here's what I mean when I'm talking about reasoning and problem solving tasks. Importantly, it's a problem where you don't know what the answer is, nor do you know right away how to get the answer. If you already know what the answer is, the problem is solved. You're done. And if you give students a problem and they already know what to do, they don't have the answer, but they know what to do, they're probably engaging in practice. And while practice is an important part of math, practice is very different than reasoning and problem solving. So while I'm not discrediting the practice that your students might need, you also need to give your students some reasoning and problem solving tasks where they don't know what the answer is. They don't even know how to get the answer right away. And that's going to require some effort on their part. And it might even involve, shall I say, some struggle. And that's going to be a good thing. And those are the tasks you want to give your students on a regular basis. And while it might not necessarily be solved in lots of different ways, but it can be represented in lots of different ways, whether it's drawing a picture, maybe a graph, you might use some numbers, lots of different ways you can go about thinking about the problem. And when giving your students this problem, I want to recognize that on our journey to become expert problem solvers, all our students might be in different places. And it's important to note that we don't want the struggle to be unproductive. So one thing you might want to try is giving your students different options about which tasks to work on. So here you have, well, a mild, a medium, and a spicy. And as it suggests, the spicy version is, well, just that. It's really spicy. It might be a little more involved, but it's the exact same problem as the mild. The only thing that's changed is the numbers. And importantly, the numbers are such that now with the mild version, if I wanted to use manipulatives, if I wanted to get out some actual cupcakes, or if I wanted to get out, I don't know, some coins or some pens or something, like I have 15 things laying around that I can use to represent this situation here. Or I can even draw it out. And 15's realistically, I can draw out 15 circles or cupcakes even, and then I can start thinking about how these things might be organized. I can even try guess and check. 200, on the other hand, the spicy version, that might be a tall ask for students to write out 200 of those things. It's doable, but probably not efficient. So it really encourages students to maybe do something differently, maybe represent things in a different way. how can I represent these 200 cupcakes without drawing all of them out, sort of a thing. And then the medium one is the one that we worked on. And that's sort of right in between. And that's maybe where you want to start with your students. Importantly, if you want to use this strategy, you want to give your students the choice of which problem to work on. We don't want to let our biases or our opinions about our students show up and saying, oh, I think you need this mild one, or, oh, I think you could do the spicy one, because those are sending our students messages. Choice is really important here. So if you want to give your students 3 different versions, or maybe just 2 different versions of the same problem, allow them to choose. And they might choose a problem that you don't agree with, and that's okay. I think that's also telling too. Maybe you think a student should do spicy and they choose mild. Well, that's telling me that maybe they're not confident enough, and maybe I should do some work to help boost their confidence so they feel like they can try the spicy. Or maybe you think they should do mild, but they really want to do spicy. Great. So now they're after it. They're going for it. Now we want to make sure that we can support them, and maybe we want to spend some more time. So when we see that struggle become unproductive, we're right there, not to save them, but to offer them some resources so that they can continue to struggle productively, which is what we're going to talk about next. So supports. What are some ways that we can support, not rescue our students from the struggle? Well, a couple of things. First, when students are engaging in reasoning or problem-solving tasks, they might be going through this 4-step process that you see here. This was from a book from Polya, who wrote a book called How to Solve It, and it's a classic book you can see here, written in 1945. And in this book, he described this 4-step process of problem-solving. And this 4-step process stuck around for so long that you can even see it in the math practices that we're utilizing today. Sorry, I should have said, so this 4-step process, first you got to understand the problem. That's really important. Before you can solve a problem, you have to understand, what is this thing asking me? Then you want to come up with a plan, and you want to carry out the plan. And then importantly, we want to look back. Did I answer the question I set out to solve or to answer? Does it make sense? Is this something that realistically answers the question, or is it maybe something I've missed? Anyhow, we can see these same things in the standards that we're engaging our students in. So it says, you can see the highlighted thing, mathematically proficient students start by explaining to themselves the meaning of the problem. So they're understanding the problem. And then later on, you can see they plan a solution pathway. And while you don't see them carry out the solution pathway, you can see down below there, mathematically proficient students check their answers after reflecting. So I think that sort of implies there that our students not only came up with a plan, but they carried the plan out to get that answer. And now they're going back to check it out. Importantly, this problem-solving process is not linear. You might start understanding the problem, you come up with a plan, and then you realize, wait, I don't know if I'm really understanding this problem yet. So maybe you go back, or maybe you get all the way to an answer and you realize this doesn't answer the question. So you got to go back to the drawing board and try over. Anyhow, you might find yourself all over the place with this problem-solving process, and that is normal. It happens all the time, and not something that should be interpreted as a sign of being less than or not as good as problem solving as somebody else. So that's important, because if your students are in different places, you want to offer them different supports. So let's say that your student is working on trying to understand the problem and they're struggling. Well, in that case, you might want to give them, as a support, a strategy called read 2 ways. And in this strategy, you ask them to read the problem multiple times. The first time you ask them to read the problem and just talk about the context. Then you ask them to reread the problem. And this time, you ask them to identify the important quantities that are involved in the problem. Maybe even ask them to draw a picture. If this sounds a little familiar, good. This is exactly what I asked you to do in the beginning of this webinar when we worked on the tray problem. And I asked you first to write it in your own words and then draw a picture that used the quantities. And you might actually have done this already naturally if you've had to read some dense text or some informational text. I do this all the time, where you read something and then realize, oh, I maybe missed something, right? Let me read this again. I'm not quite sure I understand this. So you're going back and reading it multiple times. And so really what we're doing is just helping our students develop this strategy that many people have already developed as a reading strategy, is to read and reread to make sure that we're getting the important information. So let's say, for example, we give our students the cupcake problem, and our student says, help, I don't know what this problem is asking me to do. All right, well, one thing you can do to support your students there is to engage them in a 2 reads. So ask them to read the problem and describe it in their own words without using any numbers. Just talk about the context. What's going on? Then ask them to draw a picture, and this time see if you can use all the numbers in the problem in your picture that you're drawing. And through that process to help them come to their own understanding of what the problem is asking them to do. But your students maybe understand the problem and they maybe are struggling somewhere else. Maybe I know what this problem is asking me, but I don't know how to solve it. Well, then we want to not ask them to do a two reads because that's not going to support them where they are. So we want to come up with something different. And in this case, one strategy we can use is called affordance. It involves the three things that you see here. We want to acknowledge the struggle to help our students, or remind them rather, that the struggle is important. We want to paraphrase what they're thinking or what they're being asked to do. And then we want to encourage them to use all the resources that are available to them. In other words, we want to afford them the opportunity to work on the task on their own. So same situation. We've given our student this cupcake problem. And they're not saying, I don't know what this problem's about. They're saying, help, I don't know what to do. So they understand the problem, but now they're in a very different place. So I'm not going to say, let's read this two ways. I'm going to say, okay, well, hey, that struggling feeling in your brain right now, that's actually normal. That's great, actually. If it don't burn, you don't earn. So this is a really important part for brain growth. After that, let's paraphrase. So here's what we're trying to do. We're trying to find how many cupcakes there's going to be. How many do you think there are going to be there? As a way to paraphrase what the problem is asking. And then I want to remind them, hey, don't forget, we got lots of all these strategies. Remember that poster? Remember that handout? Or remember that Google Doc that I gave you? It talked about lots of different problem-solving strategies you can use. Guess and check, draw a picture, work backwards, try a different strategy. Why don't you try one of those strategies? See if that will help you answer the problem. Another thing you can try, if the students don't have a resource like that, or you just want to try something different, you can also just give them a wrong answer and ask them to decide whether it's right or it's wrong, and see if they can prove it for themselves. One of the things this does is it gives them some direction. So like, well, how can I prove it? Well, let me maybe work backwards, or maybe I can do that. So you're really just inviting them into using a strategy or a tool this way, rather than have it be more open-ended, like pick a strategy and go. You're asking them, hey, let's focus on this one specific example or non-example and see if we can start there and use that as a way into working on the problem. So with that said, I want to give you a moment to think about some of the things I just shared with you. And with these questions here, just time to reflect. You don't have to put these in the chat, but if you're interested, I invite you to. What do you think is the role of productive struggle in math? How can you support that in your teaching? And how are the things that you're writing or thinking about reflective of you stepping out of your comfort zone, if at all? So I'll give you a few moments, mute myself, and then after this, I'll gladly answer any questions that you have. Sorry, I know that wasn't a lot of time, but I'm looking at the time and realizing that we have a few more things we have left to do. So if you take nothing else away from today, here are two important things that I hope you'll leave with. One is that if you want to support your students in struggle, it's really important that we help our students realize that struggle is normal. And it's just a natural part of the learning process. Learning is not intended to be easy. But it is in fact rewarding. And once they realize that they put in the hard work, they're going to reap those rewards. Hopefully they're more willing. And the second thing is that we don't want to rescue our students from struggle, even though it is hard, even though it feels like you're being mean, and your students might even feel like you're being mean. You have to know and tell them that this is not about me, it's about you. And I want you to struggle because I know that's really where a lot of the learning is going to happen. So as a support, I can use two reads, or I can paraphrase what they're going on and offer various resources for them to use. And if they struggle, they will soar. So we got a little bit of time left. I am happy to entertain any questions, comments, insights, or anything else. If you'd like to put them in the chat, now would be a great time to do so. Struggle is real, yes, and real important, I would add. And thank you for being here. Yeah, so with building thinking's classrooms, one of the things that, so someone in the chat is bringing up building thinking's classrooms, or BTC, which I think is a great and a very out of the box way of thinking about teaching math. For those of you who are interested, great summer read. One of the first chapters in building thinking classrooms is about thinking tasks. And I think that's exactly what we're talking about here when reasoning and problem solving tasks, is we want to give our students thinking tasks so that they're not mindlessly doing things. Or studenting, I think, is the words that they use in building thinking classrooms. So that's really important. Gosh, I forget the word that they use. Is it I want to say slicing, but that's not it. Scaffolding the task is really what it's about, but they use a very particular word in building thinking classrooms. Gosh, and it escapes me. Anyways, that's also, I think, an important part of like the choosing that I was talking about earlier, that we can use. And yeah, so students are working on non-permanent vertical surfaces, and you can use the exact same strategies we talked about when they're at their boards working. You can use the read two ways just as you would any other time, and you can use the affordances, which is to say that you remind them of the struggle, the value of struggle, and you paraphrase and you remind them of tools. And except in this scenario, they're standing up and working on a non-permanent vertical surface rather than sitting at a desk. All right. Well, thank you, everyone. I really appreciate all the things you're putting in the chat. If later on some questions come to you, I'm always one of those people who the questions pop up later. So if you're anything like me, as soon as this webinar closes, you'll be like, oh, here's my question. I invite you to reach out. Here's my email address. And I'm glad and happy, in fact, to keep the conversation going. So feel free to reach out or even share the good, the bad, or the ugly. Once you try these things out in your classroom, I would love to hear how things are going, and invite you to let me know. And with that, I will move to the slide here and pass it off.
All right. Thank you, Matt, so much for this engaging webinar, and thank you everyone for joining us today. Before you go, please take a couple of minutes to share your feedback using the link in the chat or the QR code on the screen. We really appreciate your feedback, and we use it to improve our future offerings. And this was our last Research Forum webinar of the school year. And we will be back in the fall with new topics. So please keep an eye out for the announcements in the fall. We look forward to seeing you next year. Wishing you a wonderful summer. Please don't forget to respond to this survey questions. We really appreciate it. Thank you.